Okay, this is the Math 2 EOCT Review Part 8. Still working on circles and spheres. Maybe, perhaps. Let's start with problem number 1. Circle has a radius of 7. Boom. Notice all my radii are labeled 7. Point P is located 18 centimeters outside the circle. So there's point P. 18 outside the circle means the distance from the edge of the circle to point P. Went ahead and drew a radius there as well. It says we need segment PT and PS tangent to the circle. So I've drawn segment PT tangent to the circle and segment PS tangent to the circle. Okay, at point T and S. So point T is a point of tangency and point S is a point of tangency. What are the lengths of PT and PS? First of all, when you have two tangents like this coming from the same point, I'm hoping that you remember that they will be the same length. So I will call it X. They will be the same. I hope that you also remember a major rule that we learned is that anytime you have a radius and a tangent, they will be perpendicular. So these are indeed 90-degree angles. These are two right triangles. Well, I need to find this X. Look at the information that we have. We don't know any degrees other than the 90. But we have sides, don't we? How am I going to find X? I'm hoping you said Pythagorean Theorem. Because, look, what we're trying to find is one of the legs of the right triangle. And we are given a leg, and we are given the hypotenuse. All we have to do is add. So, when we set out to do our a squared plus b squared equals c squared, a and b are 7 and x. So x squared plus 7 squared equals 7 plus 18 is 25 squared. So then that means we're going to have x squared plus 49 equals 625. And then we're just going to subtract 49 from both sides. And that's going to give us x squared equals 576. Then, of course, to get x by itself, we need to take the square root of both sides. So square root, so that's going to give me x equals 24. So that is the answer to problem number 1. X is the length of PS and PT, and that's what we were supposed to find. Problem number 1 is done. Alright, let's move on to problem number 2. Now, I drew these pictures, so you were not given these pictures in the first place. So that's sort of a hint to you. Half of the battle is drawing the picture. So when you read these problems and they're describing circles and chords and tangents and things, you need to, as carefully as you can, try to draw a picture that fits the description. So it says we need radius of circle O. When they say circle O, please know that that means O is the center of the circle. Right? Point O is the center. What else does it say? The radius is 20. So look at the circle I've drawn. There's a radius. That's 20. From O to J, that's a radius. That's 20. O to K, that's a radius. If I needed to label it, that would be 20. So just keep that in mind. So far, I wouldn't have really known exactly where to draw these radii, but read on and you'll see why I drew them where I did. I needed chord JK that is located 4 centimeters from the center of the circle. Okay, look at that part. Chord JK. So here is chord JK going across the circle. That's a chord. And here's the 4 centimeters from the center. When they say distance from a point, they mean perpendicular distance. So I just made sure that it was perpendicular. To help me see that perpendicular is why I drew this vertical line, the diameter of the circle. So it would easily show the perpendicular. So that explains the picture that I have drawn. Now, I drew 2 separate pictures for A and for B. They're mentioning chord RS. That's going to show up in another picture. But look at part A. What are the lengths of chords JK? So let's start with this. The picture I've drawn so far is designed to give me JK. So focus on that. JK is this chord all the way across the circle. Now my strategy will be, let's find the length of this side of the chord, and then we'll double it to find the whole thing. How am I going to find x? Hopefully you just said Pythagorean Theorem. This is a right triangle. We have a leg and the hypotenuse given. So if we do a squared plus b squared equals c squared, this is going to become x squared plus 4 squared equals 20 squared. That means I have x squared plus 16 equals 400. Subtract 16 from both sides, and I have x squared equals 384. Now I need to take the square root of both sides. And that gives me x equals 8 radical 6. Okay, that means this is 8 radical 6, which means this is 8 radical 6. So if I want the entire distance all the way, double complete rainbow, this is going to be 16 radical 6. I just add the 8 plus 8 and keep the radical 6. That's how you combine like terms. So that is the answer to that part. JK is 16 radical 6. I could get a decimal if I needed to, but for now I'm going to leave it as JK is 16 radical 6. We're supposed to find RS. I'm going to leave that for the next picture. In fact, let's go ahead and discuss. RS is located 10 centimeters from the center of the circle. So I should draw pretty much the same picture as before, but instead of drawing RS 4 centimeters from the center, I'm going to put it further down, 10 centimeters from the center. So let's see how that works out for us. Okay, so as you can see, pretty much the same picture, but instead of 4, this is now a 10. So this is now RS. Well, it's really the same problem twice. Once again, if I want to find RS, I will find x here, and then I will just double it. So, one more time, using the Pythagorean theorem is going to give me x squared plus 10 squared equals 20 squared. So that's x squared plus 100 is equal to 400. Subtracting 100 from both sides gives me x squared equals 300. Taking the square root of both sides, I get x equals 10 radical 3. So that means this is 10 radical 3, and this is 10 radical 3. Oh, guess what? Alright, it would have been a little bit quicker if I'd used my special triangle knowledge. Okay, in retrospect, looking back, see how the 20 and the 10, see how 10 is half of 20? Well, that's only going to happen if this is a 30, 60, 90 triangle. Remember, the short leg is half of the hypotenuse when this is a 30, 60, 90 triangle. So if I had noticed that, then I immediately would have known that the long leg here would be the short leg times radical 3. That would have saved me a little bit of time. But it's good for you to see that you will get the same answer even if you do it the long way using the Pythagorean theorem. Anyway, we're supposed to find the length of RS. So again, if I have 10 radical 3 and 10 radical 3, tell me what the whole length will be. I am really hoping that you said 20 radical 3. Sometimes kids think that when I have two lengths and I want the whole length, I multiply. But that's wrong. I need to add. So 20 radical 3. Okay, so that's the answer to one of the questions. Okay, so we're supposed to find RS, and we just found that that was 20 radical 3. We're also supposed to find the measure of angle ORS. I might have just done that by accident. ORS. Okay, so angle O to the R to the S. Well, that's going to be just the same as what I did over here. I could have just done it on this side. This is going to be a 30, 60, 90 triangle. And again, I know that because the 10 is half of the 20, and that only happens when it's a 30, 60, 90 triangle. So the answer is 30 degrees. Okay? Now, say if you didn't notice the thing about the one leg being half of the hypotenuse, and say if you didn't realize that it was just going to be a 30, 60, 90 triangle. Again, there's a long way to do it that you might need if you don't notice some of these things that are popping into my head. You'd have another shot at it if you were to use, you know, tangent, sine, and cosine. Okay, so let me back up and pretend that I didn't know. Let me pretend that I don't already know that this is 30 degrees. Instead, I'm going to call this theta. Okay, if this is theta, and I can just use the 10 and the 20. I don't need the 10 radical 3 that I just found. Using the 10 and the 20. 10 is opposite of theta, and of course 20 is a hypotenuse. Opposite, hypotenuse. Well, my friend, that is the sine function. I feel like switching colors for some reason. Let's go green. So, if I said sine of theta equals, that's opposite over hypotenuse, so 10 over 20. If I want the angle, I could do the inverse sine of 10 over 20. Okay, so if I do the inverse sine, that will give me theta. So let's see, inverse sine of 10 over 20. Just one more time, let's go ahead and do that on our calculator. So inverse sine, so I need to hit second sine for inverse sine, and then I can just do 10, use our n over d button, 20. Okay, and we do get 30 degrees. But we already knew that. Okay, so either way, the answer is 30 degrees. Alright, so that's it for problem number 2. Let's see what we have here. Number 3. Circle O, radius R, centimeters. Okay, R equals 6. The radius is 6. How far outside the circle is point P if the two tangents from point P form a 60-degree angle? Okay, so they're talking about point P with two tangents coming from them. Zoom out a bit. Okay, so this is the situation. Here's point P. There's a tangent. There's another tangent. They told us that the angle between the two tangents is 60 degrees. Alright, that's why we could deduce that this is 30 degrees and 30 degrees. That's where those numbers came from. Now, we are supposed to find this distance right here. Okay, that is our goal, because the question said how far out from the circle is point P. So we're looking for that distance. Alright. So, what shall we do? Well, 30 degrees. If we remember the very important property that we learned about a radius and a tangent, then we remember that a radius is always perpendicular to the tangent. So this is a 90-degree angle, a right triangle. 30 degrees, that's a very special angle. This is a special triangle. 6 is the short leg because it's across from the 30. That means the hypotenuse. I feel like I may need thicker ink. Okay, let's talk about the hypotenuse of this triangle, all the way from here to here. If the short leg is 6, then the hypotenuse is going to be 12. Now, can you tell me what this distance is right here? How long is this little guy? Well, I'm hoping you were saying that it was 6. And the reason why it's 6 is because it is a radius. The radius is 6, so I've got one here, that's 6. I've got another one there, sure, that's 6. But this is also a radius, so it will be 6. Well, we're ready to answer the question, aren't we? If the whole thing is 12 and this radius red part is 6, then what is the length of the missing piece that we wanted? Of course, it is also 6. 12 minus 6 leaves 6. So that's the answer to the question. P is 6 units away from the circle. Just double checking. Okay, how far outside the circle is point P? 6. Alright, well that was part A. What about part B? Is there a part B? Okay, looking at part B. In terms of R, how far outside the circle is point P under the same circumstances? Alright, so we're still being asked for the same thing, just we're not going to use the 6, we're just going to leave R in the answer this time. So we're still being asked to find this length right here. But we're supposed to use r. So here we go. R again is the short leg. If r is the short leg, that means that the hypotenuse is 2r. Okay, r is the short leg, so the hypotenuse is going to be 2r. 2r. Now, again, since radius, this is another radius right here that I've just drawn in red. That's another radius, so I could call that r. So this missing part over here that we're looking for, how am I going to find an expression for it? What would be an expression for this piece? Again, if we know the whole thing and then we know part of it, what operation do we have to do to find the missing part? Well, we need to subtract. We need to start with the whole, subtract the part that we know, and that will leave the rest. So an expression for this could be found by doing 2r minus r. But this is something that we can go ahead and do. It's sort of like having 2r minus 1r. If I have 2r's and I take away 1r, that just leaves r. Okay, so in terms of r, the distance from the circle would be r. Okay, and that makes sense. Looking back at the other one, when it was 6, we got 6. Now we can see no matter what it was. If this was 5, it would be 5. If this is r, this will be r. Okay, let's see what's next. That was number 3b. Alright, let's look at 3c. Similar question. How far outside the circle is point P if the two tangents from point P form an angle of 90 degrees? So same situation, but instead of 60 degrees, we're told that this angle right here is 90 degrees. Which of course means if we split it up, then that's a 45-45. Which means we can use our special triangle knowledge. And the way our special triangles work, if this is a leg of the 45, this is r, then that means this is going to be r. And what will be the length of the whole, the hypotenuse here, will have what length? The hypotenuse will be r radical 2. Okay? Now that's the whole distance from O to P is r radical 2. Now remember, we're trying to find just this little distance out here. The distance outside the circle. That's what we're looking for. Now, let me ask you this. Do we know this distance right here that's inside the circle? I mean, I'm talking about an expression for it. What's an expression for this distance right in here? Well, that's r. Radius, radius, radius. This is a radius, so I'm going to call that r. So here again, if I want this little part that's on the outside, what operation am I going to have to do? Yeah, if the whole thing is r radical 2, and this part, the first part is r, I should subtract, and that will give me the leftover part. So an expression for this highlighted part should be the bigger part, r radical 2, minus, the whole thing minus the part, and that should give me an expression for the missing other piece. So that's the best we can do with that. There's no real combining of like terms per se. I mean, if this were a multiple choice test, they will either write the answer in this form, or there's one other thing they could do. Do you see a common factor between these two terms? A GCF, if you will? Maybe you're noticing that R itself is a common factor. So you should be ready for this, just in case. They might write the answer in this form. They might pull out the GCF and factor that out. What's that going to leave inside the parentheses if I do that? That's going to leave radical 2 minus 1. So they could write the answer in this form as well. So watch out for that. Alright, so that's number 3, part C. Oh, I guess that's the end of this assignment. Any questions? Just kidding.